Hey everybody, solving quadratic equations, part 4 on the quadratic formula. And the quadratic formula is very powerful and not very convenient, but when all else fails, factoring, completing the square, any of the other methods, including your brain, if your brain starts failing you and you just don't remember how to factor, the quadratic formula will always work and yields the same answers that any of the others would yield. However, sometimes those other methods don't work, so the quadratic formula obviously is kind of that trump card. So let's go ahead and get into some examples using the quadratic formula. Before we do that, let's review what the quadratic formula is. Okay, here we have the quadratic formula. This is in one form that you might see. The x values that are solutions to ax squared plus bx plus c, provided that this is in the form ax squared plus bx plus c equals 0. This must be a 0 in order to use the quadratic formula. Okay, so we're going to use this, negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Okay, a is the coefficient of the quadratic term, b of the linear term, and c is the constant. So the first step we need to do is make sure that our equation is equal to 0. Then we can use this formula. So let's go ahead and get started. All right, so let's look at number 1. Number 1 looks like we've got a equal to 1, b equal to 8, c equal to 11, and our equation is equal to 0. So we're ready to use the quadratic formula. Let me write these out. A equal 1, b equals 8, c equals 11. So as we go through this process, opposite of b, or negative b, is negative 8 over 2a, which is 2 times 1, plus or minus the square root. B squared is 64 minus 4ac. Okay, so 4 times a is 4 times 1 times 11 is 44. So minus 44 all over 2. Okay, so let's do some reducing. That would give me a negative 4 plus or minus the square root of 24 over 2. Okay, now your teacher might be okay with you leaving your answer like this. However, the square root of 24 can be reduced to 2 root 6. Now that 2 will reduce, giving us negative 4 plus or minus the square root of 6. Okay, there's our two solutions to that quadratic equation. Let's look at the second example. I see that I've got a 9 here, so what I'm going to do is I'm going to adapt that. A mistake here would be to say that c equals 10. C does not equal 10. C equals 1. Now, if you're not sure what method you're supposed to use, now this is the quadratic formula set of notes and examples, but if you were not sure, you could test, see if you could factor. We're not going to do that here. We're going to use the quadratic formula, but you'll see in a minute that you actually could. A equals 1, b equals negative 2, and c equals 1. So I've got x is equal to the opposite of b, which will be positive 2, over 2a, which will be 2 times 1, plus or minus the square root. Okay, b squared is negative 2 squared, which is 4, minus 4ac. 4 times 1 times 1 will also be 4. So what you'll notice here is that I'm going to get 1 plus or minus the square root of 0. That means there's only one solution. How's that even possible? Well, how that's possible is that potentially a quadratic can touch the x-axis at only one point, in this case, the point 1, 0. So there's an example of getting one solution. You can get two solutions, or you can also get 0 solutions. Okay, as we look at problems 3 and 4, 3 is in the form that we want. So a equals 2, b equals negative 3, c equals 6. The little man got himself into the video there. Good for him. Okay, so here we go. So x equals the opposite of b over 2a. So 2 times 2 is 4, plus or minus the square root. B squared, which will be 9, minus 4 times 2 times 6. So 4 times 2 is 8, times 6 is 48. Okay, you might already see it coming. but I'm going to get 3/4 plus or minus the square root of negative, what would that be, 39 over 4. This right here is going to yield us a problem that's going to be an imaginary number. Therefore, just like it was with other methods, when we take the square root of a negative number, there's no solutions. So what would that look like visually? Well, potentially that could look like this. Right? There is nowhere along the x-axis where the equation touches that x-axis. Therefore, there are no solutions. Okay, let's look at number 4. We got to get this in the correct form first. We don't have the true value of c yet. If I subtract 6, I'll get plus 1. So a is equal to -3, b is equal to 1, and c is equal to 1. So we set it up, negative b over 2a plus or minus square root b squared minus 4ac. So be careful here. 4 times -3 is -12 times 1 is still -12. So I'm going to get x is equal to 1/6 plus or minus the square root of 13 over 6. Now, I showed the quadratic formula in a different form on the previous page, but you can also compact it like this and write your answer as 1 plus root 13 over 6, or plus or minus, sorry. There you go. That's your solution there. You have 2 of them. Of course, in this example, and this is some extra knowledge here, but that quadratic is opening down. And I don't know where 1 plus root 13 over 6 is, but I know it's positive. And 1 minus root 13 over 6 is negative. So the graph probably looks something like this. And there's our 2 solutions. Right, where this would be the negative and this would be the positive. There you have it, guys. Quadratic formula used to solve quadratic equations. Have a great day. Let me know if you got some requests for content. We'll see you in the next video.